Well, you've seen all five of my Aloha shirts now, so I'll have to think of something new to wear that will be bright and festive and fresh. Oh, it's hard to be fresh though, day after day. Yes, it is. Uh, and when I do any activity, I like, if at all possible, to break it down into three parts. It would be equivalent to a beginning, a middle, and an end. But I like to call it a trinity, which sort of unifies all three parts into one complete whole. So, this talk on unity wasn't planned to be a three-part series, but it's turning out that way. I might mention that happened too when I was taking the best of my rock and roll collection, which I copied from CDs from the Morristown Library. I have a vast library of not only rock and roll, but everything else. I copied a lot of other things too, but in the arena of rock and roll. And I've come to find out there's a close association I have with rock and roll now and marijuana. And I find it's like a youthful driving force that I get from listening to rock and roll. And yeah, the young rock stars, they burn out quick, and they have a seem apparent life a short lifespan, with a few exceptions for the ones that I like. Eddie Vedder. All their names leave me now when I try to think about it. Yeah, REM, Michael Stipe, Lou Reed. Lou Reed, Velvet Underground. Lou Reed sort of is a Dylan to me in that after the Velvet broke up with a few minor exceptions, I haven't cared for his style or his work in video. But getting back to my point of the Trinity, I taped, it was like the creme de la creme, the best of my favorites, which really dealt with heavy, amplified guitars. The more guitars, the better. Oh, I can't leave out my tragic hero, of course, Nirvana. Yeah. And getting into the darker side, Jane's Addiction, anything with heavy guitar amplified, more than one, backed up by rhythm guitar, backed up by heavy drums. That's my style. And in fact, the Trinity, I call it the Holy Trinity, drugs, sex, and rock and roll. And it's probably more drug inspired music than sex inspired music, and it's all rock and roll. Except on that Trinity, yes, I had too much for one 90-minute. I'm still working with cassettes. Too much for one 90-minute cassette, which I was originally planning, and then I went into two, and then I had even too much for two. So then that got me on the Trinity idea, especially since drug, sex, and rock and roll is a Trinity. And so I went to a third, but I ran out of gas before I got to the end of that tape. So honestly, I started throwing in things of interest that weren't related to my rock and roll library. But not to waste your time, let me get back to focus on my Aloha shirt. Yeah, I wanted to tell you the story on those five. So I have fond memories of graduating from the University of Hawaii in '65 and driving a taxi thereafter for about 6 months before I had to worry about the draft. But I was fortunate enough to get in the Air Force, and actually we flew back to Hawaii over the weekends. We call them a Hickam turnaround, flying cargo over there. So it was really cool. But Gail and I took a memory tour, as I know I've mentioned before, and one of our bets was that I wouldn't know my way around, when I got there. Well, duh, I lived there for 3 years and I drove taxi for 6 months. I think I know my way around. But immediately out of the airport, I could see there was a whole second level of highways now. The old Nimitz that I know is now like under a bunch of interstates, and God, you can go across the island in no time. So it's all very well connected, but underneath all that, it's pretty much the same, just developed to the gilt. Sandy Island was, or not Sandy, Sandy Beach. I remember before there's anything at Sandy Beach other than Sandy Beach. And I remember before the what do they call the World Sea Life at Makapu. I remember when that was built. So yeah, I have very early memories here. And to delve off even further, I remember that spearfishing was totally legal, even in Haunama Bay. And my best friend got me involved in that. We had, one of these real long spears, and I feel regretful now for the fish that I speared because it was just for sport. And most of those exotic fish aren't good for eating, except what we'd always say is, well, Filipinos will eat that because the Filipinos would feed their family by net fishing, and whatever they would catch, they would apparently, be able to eat. But I was never much on fish anyway. But let's get back to the point here. So, and I have notes again. But they're pretty cryptic, so I'll have to work to stay tuned here. And I'm going to have to work to relate this to unity. But I'll manage somehow. It's more related to science. But before we start, I must ask if there's any old business, and I must say yes. There certainly is old business because I felt I did not deliver as promised on that last lecture, which is a big reason for this one. Because I didn't translate what I ended up saying into a definitive statement that would answer really the question. And let me back up for those unfortunate few that didn't or haven't yet seen my second talk on unity dealing with, I was going to say Captain Nemo. Zeno, one of his paradoxes about the arrow, and the example was I was shooting you with an arrow that took 1 second to travel the distance, but the apparent paradox that I mentioned was, well, at any point in time during that 1 second duration, the arrow is not moving. And there would be no disagreement because by definition, a point in time has no duration. So then at all points in time, therefore, at all points in time, take anyone, the arrow's not moving. You look here, it's not moving. Look here, it's not moving. Okay, so the conclusion is then that the arrow's not moving. And so the question was, not the question was, but then I ask you to answer this paradox. And if you can't, I shoot the arrow to see what happens. Of course, we know what happens. So it's just a stage. And I gave all this stuff. I'm sure if you did listen to it, you don't want to hear it again. But yeah, I didn't draw the conclusion, which might not be obvious. And in fact, it was so not obvious to me that until I was told, I didn't get it. So if you haven't gotten it, this is it. And so this is the epiphany. So the epiphany is that this is not a paradox. It is true that the arrow is not moving at any point in time by definition. And it is true that it is not moving at all points in time. But it is not true that the arrow is not moving, obviously. But why isn't that true? It's because the arrow, here it is, drum roll, only moves within time. And all of those points have no time. So there's no time. But the movement is between the points. So you have to have a duration to show movement. So, just because you take and add together all the points in time doesn't mean that there's no movement, because obviously there is, because when you look at my, secret other Jello machine reader and type in that infinitely long number, you get an infinitely long number back. It's different than if you type in a different number. So that's the epiphany, that the movement is across time. So that to me was very enlightening, and it helped settle my thought about that apparent paradox. And I'm not sure whether Zeno got it. I don't think Zeno got it, because Zeno was really of the opinion all motion is impossible. It's absolutely impossible because of this infinite regress, that you can't span an infinite number of points in a finite amount of time. But the reality is you can, and if you couldn't, Zeno would be right. There wouldn't be any motion. So I'm looking at my notes now, and the conclusion of this series now, as Trinity. Hopefully that will bestow some enlightenment upon you. And I would like to say that I feel like those guys on TV, I can't think of their names right now, that try to make math or science interesting. And I think they do an excellent job, as do the science centers. It's certainly a good thing, to teach kids what's going on, in the real world, because they're going to have a hell of a, they're going to inherit a hell of a mess of a hell. How did that? I forget how they said that. But my father had a saying like that. But anyway, yeah. So today's topic is the elusive electron. And I had a thought on how I am relating this to unity. I don't think this was it, but I can relate it to you this way. There's a reality going on in my head, that has some basis in fact. And I'm sure the same is true of you. Both a little different. We're looking at the same thing. We have our different interpretations, like whether that was really an echo or not. Gee, I thought of another analogy too on that topic. What was it? I can't remember. I'm starting to waver off my topic. So, yeah, how do I relate this elusive electron to unity? Well, the electron is a quantum particle, so it makes it interesting enough to deserve its own special talk. And we run into some of these conundrums, I'll call them, which to me means something that doesn't have an answer, or might have an answer, but we haven't found it yet, or our thinking isn't such that we can comprehend its complexity. Mm. Yeah. So being just a quantum particle, it involves our consciousness. So it involves the same kind of centers where this unity is going on inside my skull. So I just wanted to talk about the electron and elevate its status of importance to our existence. And I might make a diversion I didn't put in my notes, but I did think about this. I've mentioned, I think, before the anthropic principle. And when you ask the question, well, how is it that so many coincidental things happen that we developed? Well, the answer is, well, if it happened otherwise, you wouldn't be here asking the question. So it's sort of a unfulfilling answer to the question, and I would say this: if the electron didn't work the way it works, you know, I wouldn't be here talking to you, and you wouldn't be here listening to me. The world would be quite different. Fortunately, it seems like the whole universe is based upon the principle of quarks and electrons building up all the way to complex entities like you and me that are able to conceive of a continuum of reality. But I'm leaving the electron and going too much to consciousness, I think. So let me just bring up the first thing that wasn't obvious, and what I like to try to act here is like a translator because I've done a lot of studying and reading, obviously, in the fields, and don't want to describe them in so much detail that I lose your interest. So I like to move along, but I like to humanize them to make them understandable. And so people understand the significance of and appreciate the reality of their existence. So, yeah, the first thing that I wanted to mention is it's the electron, I will say, is considered by science. They don't say it is, they say it is considered a point sized particle. And that maybe doesn't hit home what that means. That really means it's not like a little baseball because it has no dimension. So it really does not exist. I mean, as a sphere, a very small sphere out there, a little baseball somewhere that we think of that orbits around nucleuses of atoms. And I might say it serves our every need here. We wouldn't have this cyber connectedness if it weren't for those little electrons running around and doing their thing for us and enlightening and comforting our lives to the extent that we think the man is the measure of all things and all else must yield. Well, it'll yield until it'll break, and then you'll be a king of nothing. I strongly suggest you watch Werner Herzog's excellent film of the 70s, Aguirre, The Wrath of God. Klaus Kinski plays an excellent role, and just listen to him. And if he doesn't represent humanity, back to the electron, yeah. So being a point-sized particle means it has no volume. Okay, but it does have mass. Okay. Uh, so, I mean, what that means is it's infinitely massive, which is a black hole. So, I mean, there's sort of, I would say, compromises that had to be done. And to follow this even further, and I might be understanding this correctly or not. I think I've got it approximately correct, and I'm just going to translate it to something that's a little more interesting. So, therefore, when they start doing their calculations and their formulas and figuring out stuff, it becomes a problem to have something infinitely massive and having to go to its absolute what would be center before you hit the thing. And this, I'm understanding, causes a lot of equations to have infinities with them. Which, when that happens, and that happens, when they apply relativity to black holes, that's the holy grail, quantum gravity, which string theory is trying to provide. But God, I'm losing my track here. Yeah. So where was I? Yeah. So So to get rid of these infinities, science sort of had to get in bed with maybe some procedures that weren't, well, let's say, according to Hoyle. I mean, they would be under suspect of maybe, cooking the books. And this comes from one of my idols in science, Richard Feynman, because he is such a free thinker and had such an interesting life and was involved in so many things and was also happy to toot his own horn. So there's a lot of stuff, books that he's written, books about him, his lectures. Yeah, so I know a lot about him. But anyway, he came up with this procedure that was called normalization, which he or nobody seems proud of, but seems to be used throughout science to get rid of these infinities when I understand, doing calculations about, interactions with electrons. I think that's approximately correct. But another interesting thing, and this is really more of the reason why I'm bringing up the electron other than its point size, is, well, I mentioned yesterday the quantum leap that the electron takes, where it goes from one shell in an atom to a higher energy shell instantaneously without transversing any of the intervening space. I mean, that is very bothersome. But being this quantum particle, I hope you're familiar with the concept of superposition. When I mentioned the electronic cloud or electron cloud yesterday that a electron orbits in. Now, and I might mention too, when scientists try to look, at the electron, it's the energy levels just go to infinity also. So it's like an infinite energy source with infinite mass at this point in space that has no volume. So it's a very difficult to get your mind around. But assuming that it is that kind of thing, you're thinking, well, it's going around in the cloud and it's here and it's here, that it's, you have to drop this concept of an atom being a little solar system. And even this electron now being restricted to this cloud, it really does not have a position. And I'm going to drop off here now into this aspect, which, is the most bothersome at all. And this was the famous Einstein-Podolsky-Rosen debate with Niels Bohr at the Solvang conferences in the 30s over what the meaning of quantum physics was, and I don't want to get into that again because it's been explained a lot of times and you can hear it better from other people.